What a beautiful day! You know, when you think about it, the life cycle of every plant is quite the unique journey. They evolve numerous stages, during which the plant will change both structurally and genetically. This process is known as the alternation of generations. In this video, we'll be focusing on the life cycle of bryophytes. Ah, perfect timing. So much for that beautiful day, though. Life can't happen without water, and this is especially true for the bryophytes. Unlike flowering plants and conifers, they depend on moisture to sexually reproduce. So on a rainy day like this, it's the perfect opportunity for them to start a new generation. Let's take a look at the moss on that log over there. Mosses are classified as bryophytes. Members of this group are non-vascular. Despite this, bryophytes remain complex in structure. Just like a wool rug, this moss bed may appear simple, but in reality, it's composed of hundreds or even thousands of small individual organisms standing together as a single unit. Don't believe me? Take a closer look and see for yourself. Closer. Closer. You know, that's just a little bit too close. Can we back it up a little bit? There we go. That's much better, thank you. Here we have a male and female moss. Yes, you heard me right. Mosses possess either male or female sex organs, requiring the genetic input of two plants of the opposite sex to reproduce. In addition, the male and female counterparts of a bryophyte each have a distinct shape and internal structures that make them easy to distinguish. This plant is a male, as can be seen from its antheridial head, which creates and holds sperm. In contrast, this one is a female, defined by its archegonial head, which houses the eggs. Let's first focus our attention on the female. This lovely lady is fully grown and ready to release spores, indicated by the mature sporophyte growing off the top of her head. The sporophyte is the asexual generation of the bryophyte, consisting of a single capsule capped off by an operculum. The capsule contains all of the spores of the next generation, while the operculum keeps them tucked inside until it's time for them to be released. And it looks like that time is now. Whoa, did you catch that? Let's watch that again in slow motion. As the rain hits the sporophyte, a thin layer of cells holding the operculum shut dissolves, allowing the tightly compacted spores to burst out. The spores, having been created through meiosis, carry only one set of chromosomes from the sporophyte. This makes them haploid, or 1N. Each of these spores will grow into an individual of one of the two sexes. You see, each male and female plant is actually a haploid individual called a gametophyte. This means the haploid generation of the bryophytes is the dominant generation, or the stage that we identify as the main plant. Looks like our little moss is all grown up and ready to reproduce. They grow up so fast. Judging by the antheridial head, we can tell it's a male. Each of our friends' antheridia contains thousands of sperm awaiting release into the outside world. When the rain comes, drops will land on the antheridial head and splash the sperm away, hopefully to a female plant nearby. Without the rain, these sperm would never be able to make their journey, and yet many still won't reach their destination. However, those that do make it have a chance at fertilizing an egg in one of the female's many archegonia. The archegonium houses and protects the egg at the bottom of its long tube. Only a few sperm from the male will actually make it to the archegonia, and only one will fertilize the egg. If more than one egg is fertilized at a time, the gametophyte will systematically abort all but one of them. Oh, it looks like we have a winner! Now that the egg is fertilized, it becomes a diploid zygote, and will now grow into the 2N structure of the plant, the sporophyte. Bryophytes are special in that their sporophytes never become independent plants. Instead, they grow directly from the female gametophyte's archegonium and remain there until their purpose is fulfilled, which is to disperse spores. The sporophyte consists of three main structures: the foot, an outgrowth of the zygote to anchor itself to the archegonium as it grows; the capsule, a structure that holds the plant's spores; and the seta, a long stalk supporting the capsule. Covering the capsule is the calyptra, a protective shell that keeps water from opening the capsule before the sporophyte has fully matured. As the capsule grows, the calyptra will break off bit by bit until the operculum cap underneath is completely exposed, signifying that the spores inside the capsule are ready and waiting to start gametophytes of their very own. And so, we find ourselves back to where we started. The rains will come, unzip the operculum, and the spores will be released, repeating the cycle again. And there you have it, the life cycle of mosses.